Dear friends, what we mean by drift velocity, this is our today's topic. You know a metal conductor? Let I give an example like copper. What's the atomic number of the copper? 29. What's the electronic configuration? 2, 8, 18 and 1. And what's the tendency of every atom? Like electrons 2, 8 or 18. Like noble gases. So this is extra electron and it is instability for the copper. So to be stable, copper loses this electron. Now what happened? This is a conductor. And in this conductor, near about there are 10 raised to power 29 atoms per meter cube. Because every atom loses one electron and one copper loses electron, it becomes n positive ion. So positive ions are there. These are the positive ions. They cannot move. They are still. They remain at their positions. And then there are the electrons. These are the free electrons. I mean, this ion loses this electron. This atom loses this electron. So there are millions of electrons which are free. And the electrons, they are moving in random direction. If one electron is moving like this, other is moving like this. If it is moving along this direction, it is moving along this direction. You know what is the reason of this randomness or random velocities? The reason of random velocity is the temperature, or you can say thermal energy. So of course, every electrons moving with different thermal velocity, like maybe U1, U2, and if there are n electrons, Un, and velocities in magnitude different, direction different. But if we find what is the average velocity, of all these, then plus divided by n. The average velocity comes out equals to 0. I mean there is no average velocity. That's why there is no current. The charge is moving, but the motion is random. So that's why on the whole average it is 0. There is no current because average velocity is 0. Now then, okay, if this is a conductor, right? This is our conductor, and I apply some potential difference. Potential difference, I mean to say, if I attach a positive, negative, a battery, so what happens? This is, potential difference which I applied, it is V. Now, you know very well, there are electrons which are free. And electrons, they are negative. When they find there is positive potential, all electrons, they will be attracted then by the positive potential. So what do you think? That the electrons then, it will move in a straight path along this potential. because this potential is positive, and here the potential is negative. Here the potential is positive. Positive potential, it attracts the electrons, and negative potential, it will repel the electrons. And what do you think? Then whether the electrons, they move exactly along a straight path? No. They cannot move along the straight path. Because there is thermal velocity also. The electrons having the thermal velocities, electron having the randomness before applied of this potential. When the potential is applied, then the electrons having two velocities, thermal velocity and second the velocity because of this potential or because of the electric field which is created by this potential. Electric field is potential over electric field is potential over distance. Electric field is potential over distance. So I mean to say the electrons having randomness, random velocities because of the temperature, electron will have another velocity because of the electric field. So that's why the electron cannot move exactly along a straight path. The electron path will be like this. It will move like this. Then it will make collision with some ion or with some another electron. Then it will move along this path. It will again strike with some another ion or with some other electron. It again moves like this. Again it suffer a collision. Again move along this side, then along this side. Then ultimately it will reach at here towards the positive potential. But the path is not a straight. It is a zigzag path. So we will say the electron is drifting. Drifting means slowly it is moving towards the target. In a slow, it is moving towards some target. That is called drifting. Okay. Now if there is an electric field, because of this potential, you know what is the definition? Electric field is force upon charge. Okay. Then electric field is force upon charge. Okay. And Newton's second law, force is mass into, then what is a force by Newton's second law? Mass into acceleration upon minus c. So A becomes equals to minus E, capital E by m. Why there is a negative sign? Because electron will be accelerated. Electron will experience a force opposite to the direction of the electric field. In direction of force and direction of electric field, they are in opposite in direction. Like here it is a positive potential, here is a negative potential, then electric field direction like this. Then electron will be accelerated along this direction. This is the direction of the force experienced by electron. So both are in opposite directions. That's why there is a negative sign. Okay. Now, at any instant of time, at any instant, I mean to say, at any instant, any electron having thermal velocity u1, it is then accelerated by this electric field and acquires another velocity. You know, V equals to U plus AT. Now because of acceleration, because of acceleration there is no initial velocity. Because of acceleration, velocity is A into T. So there is one thermal velocity, and second velocity is A into tau 1. A into tau 1 means the velocity acquired because of the acceleration by the electric field. Tau 1 is the time for the acceleration, because it will make collision then. So I'm just talking just before collision, the time elapsed by this particular electron, that time is tau 1. So this becomes the total velocity, okay, before going to collide, before collision. Similarly, in the same way, the velocity of the second electron plus E into tau 2 and so on up to the nth. Then what we mean by the drift velocity? Drift velocity is the average velocity with which the electron drifts. Like electron is here drifting, okay, not moving. Moving means a straight line. This zigzag path, this is ultimately it is drifting, okay. And drift velocity, it is very, very, very small. It is 10 raised to power approximately 4 meter per second. It's a very small drift velocity, okay, because electron makes so many collisions and ultimately, it reaches to the target. So drift velocity, I mean here taking the sum of, taking the average of all the velocities. So making the average, then it is V1 plus V2 up to Vn divided by n. So substituting for V1, V2 and all, substituting here, then drift velocity becomes U1 plus U2 up to Un by n plus A is the same because the E is the same. Then tau 1 plus time is a scalar quantity up to tau n divided by n. Okay. Now I already explained the average thermal velocity. This is the average thermal velocity. It is 0. So what it is left? Only this part, and let tau 1 plus tau 2 up to tau n of n. Let I call it the letter tau. There's average relaxation, average time, average collision time. The average collision time. So average collision time. Average collision time is called average relaxation time. So drift velocity, it becomes A vector into tau. Now substituting for this A value minus E, capital E by m, then drift velocity becomes minus, it becomes minus E capital E by m, okay, and tau. So minus E capital E over m into tau. So this is the expression for the drift velocity. Okay, drift velocity is vector quantity as electric field is here vector. And the drift velocity is, of course, it is very small in magnitude always. And drift velocity of the electron will be opposite to that of the direction of the electric field. Now, one thing more, there is a factor that is called mu. Mu is called, like mobility. Mobility. What about the mobility? How the mobility is defined? Mobility is defined as the drift speed. What is the drift speed? Drift velocity divided by the electric field. Drift velocity per unit electric field. Because I'm having now the expression for drift velocity, which is equals to minus E, then I'm having the expression in magnitude. Okay, it is E tau by m. Now if I take electric field to this side, so drift velocity per unit electric field becomes E tau by m. And in general, I should say the charge is Q. Q may be electronic charge may be any other charge, because the general expression of the mobility, which is mu, and mu is equals to what? Q, because the journal is Q tau by m. Q tau by m. So if you are having electron, then it will be E instead of Q. And here the mass of the electron. And if you are having hole, what is the concept of hole? You just go through the semiconductor. Okay, in semiconductor there are two types of charge carriers, electron and hole. Then if it is a hole having the same charge in magnitude as that of electron, but here comes the mass of the hole then. There is a question for you, because very well, one thing is very clear when you go through the semiconductor chapter. What is the hole concept? The deficiency of electron is called hole. When if at a position there is no electron, that is referred as hole. Deficiency of electron is called the hole. And what do you think about the mass of the hole? What it will be? Because you just note, diamond, electron's mobility, remember the units also, 1800, and hole mobility 1200. Silicon, electron mobility 1350, hole mobility is very, very small, 480. 480 more than it is very small, of course, less than even the half value, less than the half of it. So when the hole is, the deficiency of electron is hole, then how the hole mobility becomes very less as compared to the electron mobility? This is a question for you. Please write me the answer in the description box. Okay, thank you.